Hello, this is a video that will walk you through an activity that can be given to students to have them alter existing code. So before I run through the program and show you how this can work, just again to flip to our math curriculum connected to coding in the algebra curriculum, just focusing on this activity for the junior division level, so grade 4, 5, 6 right here, focusing on C3.2. So these three expectations for grade 4, 5, 6, it's one specific expectation for each grade, focuses on reading and altering existing code and then being able to describe how changes to that code affect the outcomes. And that language is very, very similar and consistent throughout the grade levels. The only difference is that the individual skills that are taught for these grade levels up here in C3.1 are also included down here as well. So again, for the next few minutes, we'll walk you through a sample activity that can be used with students in any grade, grade 4, 5, 6 in particular, for this activity to focus on reading and altering existing code. So just to switch back to the activity, so I have a running race debug that has been created. And again, if students have access to their own Scratch account, which is the program we are using just to demonstrate this coding model, if the students have access to their own account, they can be given links to different shared programs and then click the green remix button, which allows them the opportunity to go in, access existing code, and make changes. And it becomes their very own program. It does not interfere with the original program created by the original user. So right now, the object of this program is for the two sprites to race to the right edge of the stage, turn around, and race back to the left edge. But there are some problems. And then by remixing and altering the existing code, this task can easily be connected to the grade 4, 5, 6 math-specific expectation C3.2, which is what I just outlined in that previous screenshot. So if I just click the green flag right now, you can see I have two sprites. There is a football player and another sprite underneath whose name happens to be Jamie within the Scratch library. So I click the green flag to run it. And let me keep trying. And there clearly seems to be a problem with this program because, again, these two sprites are supposed to race to the right edge of the stage over here, turn around, and then race back to the left edge. And it seems they are getting stuck. This black line looks to me right now that there is a problem. So again, with the activity being provided to the students, where the students are not creating their very own code, they are accessing code that has already been created and they are altering and debugging. And as mentioned in a previous video that you may have watched, when we talk about altering existing code, there are two ways that they can do this. One way is by debugging or fixing problems. So for example, the fact that these two sprites cannot make it to the right edge of the screen is clearly a problem that needs to be fixed. Other ways that you can alter existing code are maybe not necessarily to fix mistakes, but to just make general changes to the program to make it run differently. So if I'm a student right now, to access the code and be able to debug it or alter it, I need to click this green remix button. So I click the button provided for this activity, and this project is now saved in my own Scratch account, and I am free to remix this and change it as needed, and it's automatically saved to my account. So I'm clicking the green flag. I can see that the sprites are still continuing to get stopped on the black line. I have my three sprites down here below. I have my football player, I have Jamie, and sprite number 1, which does not have a picture attached, but just so that you know, that would be this black line that has been added to my backdrop, which is the football field. That would be sprite number 1. So to meet that expectation, students need to alter existing code and then be able to talk about how changes have impacted the outcome of the program. So the first problem I need to fix is to be able to get these sprites past the black line. So as a student, I take a look at my code, and again, as mentioned in another video, this is going to depend on a student's previous history. So if some of these concepts have already been pre-taught, there will be an advantage. Students might be able to quickly take a look at the code and be able to determine what the problems are. If this is something where students have not really been taught these prior skills yet, there could be some frustration. There will be some students who might be able to figure it out just by logically taking a look at the coding blocks, but there might be some pre-teaching that will need to take place. An example of this, I can see this control structure right here. When I say control structure, I'm talking about a set of coding blocks put together. I have my green flag, I have a forever loop, And inside my forever loop, I have a conditional statement, which is my if-then. So if something happens, touching the color black, then a consequence is going to happen, or an event is going to occur. So if touching color black, then stop all. So this piece of code here automatically tells me that the football player is coded that the moment the football player touches the color black, which is this color of line, it's going to stop the entire program. I switch over to Jamie. That piece of code is not there on Jamie's program, but it is there for the football player's program. Let me just click on sprite number 1, which is the black line. There is nothing there. So it looks like to me, again, if I am a student and I am trying to debug or alter the existing code, in order to fix this issue, this is one thing that I can adjust. So right now, I'm thinking, okay, what can I do as a student to fix the problem so that these football players can get past the black, or pardon me, the one football player and the other sprite can get past the black line. Well, if I break that code apart, detach it from the green flag, this breaks the code. Now, I should be able to get past the black line. And you can see that worked. And it looks like I fixed one problem, but there is now another issue that is happening. So both sprites have made it to the side, the far side of the stage, and now they have flipped upside down on their heads. That's a problem. The football player also on the way back to the left edge of the screen is moving incredibly slow. That's another problem. So the good news is that I have done something to my code to fix the black line issue to be able to get the sprites past the line. Now, is that the only thing that a student can change to fix that issue? And again, depending on the students in your class, some might break the code apart. They might drag the code over here and which basically deletes the code. They might change different items in the code. There might be students that say, well, what if I moved these sprites in front of the black line and then came over here and I changed the starting X and Y values of my sprites? Would that work? So again, that could be something where if you change the starting point of the sprites, that's altering the existing code to be able to fix the problem. That could work. The point being, there will be a number of students who come up with different ways and different solutions to fix the problems in the program, and that's okay, as long as those students can have a conversation with you as the teacher to explain what did they change and what difference did that make in the program. So again, a lot of what we are talking about in this video could relate to the grade 4, 5, or 6 curriculum. Now, just to kind of take this back to grade 4, we still haven't addressed the fact that these sprites turned upside down on their heads once they turned around. There might be students in grade 4, 5, or 6, any grade level for that matter, who might look and say, oh wait, we've already done a lesson on this before, and we were taught that in order to keep a sprite from rotating upside down on its head, we need this set rotation style left-right coding block. Again, if the students have not learned this ahead of time, there is going to be some experimentation and some exploring to see if anybody can realize, oh, there's a set rotation style option. And if I use that inside my code, that should be able to fix Jamie and the football player from going upside down on their head. And let me just break apart that one piece of code so I can run the program and show you what that looks like. The sprites are going from one side of the screen. You can see that Jamie has been fixed. Jamie is now rotating properly, but the football player is not. So again, as a student, I'm looking at my code and thinking, what is it about the football player? For Jamie, I've used the set rotation style, but for the football player, I haven't. So I need to fix that. Now I fixed the rotating upside down problem. Now what else do I need to do? I need to fix the football player slowing down on the way back. So I can take a look at my code and I can say, all right, on the way there, I'm moving 10 steps at a time and I am waiting 0.1 seconds. That controls the speed of the movement. On the way back, this is my code, moving 10 steps. That matches what I did earlier, but I have a wait time of 0.5 seconds. So as a student, I can say, oh, wait a minute, I have different wait times. I need to change that. So I can make an adjustment to my code and have a conversation with the teacher saying I needed to adjust my wait times to match. That sped up the speed of the football player on the way back. If the student is in grade 4, if this is being used as a grade 4 activity, You can take a look at this and say, well, as a grade 4 student, I need to understand how to create a nested event, which is a loop inside a loop, or in other words, it could be a repeat inside another repeat. So let me just quickly drag that over and show you what I mean. If in my code I have a repeat block, such as here, repeating 40 times, and inside that repeat I put another repeat, this would be an example of a nested event. This loop up here, control structure that I earlier created, in a forever loop, that if touching the color black, then forever I have an if-then statement inside a forever loop, that would also be a nested event. So nested events relate to the grade 4 curriculum. An if-then statement, which is a conditional statement, relates to the grade 5 curriculum. So if this task is being used that has any conditional statements such as if-then, that can be used as a grade 5 activity for this expectation. If anywhere in the code, students look at it and say, there's too much code, I can make changes here to make this more efficient. In other words, a shorter block of code to make it run with less memory, then that relates to the grade 6 expectations. So here's an example of how this can look. A student can look at this and say, inside my repeat loops, I have next costume twice. I don't need that. I only need one next costume. I can get rid of that. I can get rid of this. And it has no impact on my program at all. I'm using 2 fewer coding blocks. It's therefore more efficient. As a grade 6 student, I am showing the teacher that I am understanding the key skills for a grade 6. A repeat here, and then on the way back, another set of repeats. So on the way there, these 2 sprites are repeating 40 different times, a costume change and moving 10 steps, and on the way back, they are doing the same thing. If a student looks at this and says, well, I don't need all of these, because if they are doing the same thing there and back, isn't that just repeating the same movements twice? Yes, it is. So I can grab another repeat block, put it around those. It's 2 repeats. It's fewer pieces of code, therefore it's more efficient. That would be a grade 6 conversation to have. Also, by doing it this way, I have a repeat inside a repeat. That's a nested event. That's a grade 4 conversation. So again, by making some of these same changes, depending on what your focus is and how the conversations go with students, this is an activity that can be relevant for grade 4, grade 5, or grade 6, depending on the conversations you have. Again, if it's a grade 4 student, I want to be able to talk to my teacher about how I am creating a nested event, a loop, in this case a repeat loop inside another repeat loop. If I'm a grade 5 student, I want to talk about how I'm using a conditional statement. If I'm a grade 6 student, I need to be able to talk about how I am making changes to my code to make it run the most efficient way possible. So I hope this video has been helpful. Thank you.